AI is taking over the world. Well, not really, but it sure feels that way sometimes. You've probably noticed how AI is creeping into nearly every aspect of life. From Netflix recommendations to the voice assistant on your smartphone, AI is here. But what is it exactly? And how does it work? In this video, we'll break down the essentials so you can better understand this game-changing technology. Defining AI. AI stands for artificial intelligence, which refers to computer systems that can perform tasks that typically require human intelligence. This includes abilities like understanding language, recognizing images, speech or patterns, learning, problem-solving, and making decisions. The goal of AI is to create intelligent machines that can assist humans in working more efficiently, accurately, and safely, or solve complex problems that humans cannot easily solve on their own. AI has evolved a lot since its beginnings in the 1950s, when pioneers like Alan Turing posed the question, "Can machines think?" This sparked the new field of having machines simulate human intelligence. Over the years, the field has evolved, and today, AI is more about creating systems that can intelligently solve problems, understand language, recognize patterns, and even create art. But it's important to clarify what AI isn't. It's not just robots or science fiction or something to fear. In fact, AI is a tool, a really powerful one, that, when used responsibly, can make our lives better and our societies more equitable. So, now that we've laid down the basics of what AI is and isn't, let's move on to explore different types of AI, how they work, and how they're already changing our world. Types of AI. When we talk about AI, it's essential to understand that there are different types, each with its own capabilities and uses. While some people categorize AI into two types, others prefer a three-type categorization. Let's break it down. First, we have narrow AI, also known as weak AI. These are systems designed to perform a narrow task, like recommending songs on Spotify or recognizing speech like Siri or Alexa. They're incredibly good at the specific tasks they're designed for, but they can't understand or learn anything outside their specific function. Next is general AI, also known as strong AI. This is the kind of AI that has the potential to understand, learn, and apply knowledge across a broad range of tasks. It's the kind of AI you see in science fiction, like sentient robots. But as of now, general AI remains a theoretical concept that we're still working towards. Lastly, some researchers talk about a third type of AI called superintelligence. This term was popularized by philosopher Nick Bostrom, and it refers to a future form of AI that surpasses human intelligence in nearly all economically valuable work. It's a level of AI that doesn't just mimic or replicate human intelligence, but significantly exceeds it. While fascinating, it's important to note that, as of now, superintelligence is purely speculative and theoretical. So, when we talk about AI, we're generally referring to narrow AI, the AI that's already a part of our daily lives. But it's also important to be aware of these other concepts as we think about the future of AI. Now that we've covered the different types of AI, you might find yourself asking, how does AI actually work? How can a machine learn? These are excellent questions, and the answer lies in a concept known as machine learning. Machine learning, a subset of AI, is essentially a way of training an AI to learn from data, much like how a child learns from experiences. A machine learning model is given a lot of data and uses algorithms to identify patterns and make decisions or predictions based on those patterns. Here's a quick example to explain it. Say we want to teach an AI system to recognize photos of cats. We provide the system with thousands of cat photos properly labeled as cats. The machine learning algorithm analyzes these images to identify patterns and features common to cats, like pointy ears, whiskers, nose shape, etc. It uses the patterns it learns from this training data to then identify new cat photos it hasn't seen before. Over time, with enough data, the algorithm gradually improves at recognizing cats in images. Even if it makes mistakes, those errors can be used to further refine the model. So machine learning algorithms allow AI systems to learn from data rather than having to be explicitly programmed for every single task. The more high-quality data the AI can train on, the better it becomes at the task. A special type of machine learning, known as deep learning, employs structures called neural networks. These networks are designed to mirror the human brain, learning and improving over time. They are the driving force behind technologies such as voice recognition and image recognition systems. While this is a high-level overview, the key takeaway is this. AI operates by learning from data and making decisions based on that learning. In the same way that we learn from experience, AI learns from the data it's provided. The more high-quality data it receives, the better it can learn. Data and training. Now that we've covered the basics of how AI works, let's delve a little deeper. One thing that's absolutely critical for AI, especially machine learning, is data. AI systems learn from data, much like a child learns from experiences. You can think of data as the textbooks from which AI learns. The AI is given large amounts of data and uses this information to make decisions or predictions. For example, let's say we want to train an AI to recognize cats. We would need to give the AI a large data set of images of cats so that it can learn what a cat looks like. The AI would then be able to use this information to identify cats in new images. Of course, not all data is created equal. Some data is more valuable than others. For example, data that is accurate, complete, and up-to-date is more valuable than data that is inaccurate, incomplete, or outdated. In addition to the quality of the data, the quantity of data is also important. AI systems need a lot of data to learn effectively. The more data the AI has, the better it will be able to learn and make accurate predictions. Data is the fuel that powers AI. Without data, AI would not be possible. Algorithms. The algorithms are just as important as the data in AI. In the context of AI, an algorithm is a set of rules or instructions that the AI follows to learn from data and make decisions. You can think of an algorithm as the teacher guiding the AI's learning process. However, just as a teacher's biases can influence a student's learning, biases in an algorithm can lead to biases in the AI system's decisions and predictions. So, the magic of AI really comes down to two main ingredients: data and algorithms. With the right data and the right algorithm, an AI system can learn to do incredible things, from recognizing images to understanding human speech to diagnosing diseases. For example, let's say you want to build an AI system that can recognize cats. You would first need to collect a large data set of images of cats. Then, you would need to train an algorithm on this data set. The algorithm would learn to identify the features that are common to all cats, and it would use these features to recognize cats in new images. However, if the dataset you used to train the algorithm was biased, the algorithm would learn to make biased predictions. For example, if the dataset only contained images of white cats, the algorithm might learn to identify white cats as cats, but it might not be able to identify black cats as cats. This is why it is important to be aware of the biases that can exist in data and algorithms. If you want to build an AI system that is fair and unbiased, you need to make sure that the data you use to train the algorithm is representative of the real world and that the algorithm itself is not biased. Applications of AI. Can you imagine a day without AI? It might be harder than you think. AI is already making a significant impact across various sectors, often in ways we don't even realize. Let's dive into some specific examples. Autocorrect on your phone uses AI to predict what you meant to type based on your writing style and context. Why? Alexa, Siri, and other voice assistants use natural language processing AI to understand your speech, respond appropriately, and continue conversations. Netflix and YouTube use AI algorithms to recommend shows and videos based on your interests and viewing history. This keeps people engaged on the platforms. Social media platforms like Facebook leverage AI to customize your feed, prioritizing posts you are likely to interact with. Banks and financial institutions analyze transactions to spot fraud using AI, as well as assess loan or insurance eligibility. Healthcare professionals use AI tools to help analyze medical images to detect cancerous cells or diagnose eye diseases. Self-driving car systems rely on positional and navigational AI to operate safely on roads. And AI chatbots. They're transforming how we search for information and interact with technology. Popular ones like Google's Bard, ChatGPT, Claude 2, and Microsoft's Bing Chat are redefining our digital interactions. As you can see, AI is already transforming major industries from finance to healthcare. But the applications of AI go far beyond what's listed here. Virtually any field can be enhanced by intelligent algorithms capable of making data-driven predictions and decisions. But as these powerful technologies continue advancing, considerations around ethics, oversight, and aligning AI for social good remain crucial. Because remember, technology is only as good as the way we use it. Implications of AI. While AI has many benefits, there are important implications to consider as these technologies continue advancing. Workforce impact. AI automation may displace jobs in some areas, but also create new types of jobs. Continued education on working with AI will be important. Algorithmic bias. AI systems learn from data, so biases in training data can lead to biased predictions. Ensuring diverse and representative data is key. Privacy risks. The large amounts of data needed to train AIs raises privacy concerns. Policies to protect user data privacy are important. Lack of transparency. The inner workings of complex AI systems can be difficult to interpret. Transparency will help build trust. Cybersecurity. As AI systems take on more critical roles, they may be vulnerable to hacking or manipulation. Robust cybersecurity measures are essential. The growth of AI raises important questions about ethics policies, oversight for responsible development, and more. Understanding the basics puts us in a better position to guide these conversations and ensure the socially beneficial use of these powerful technologies. Conclusion. In summary, AI refers to intelligent computer systems capable of tasks requiring human cognition and sensing. While AI has made huge strides, true general human-level AI does not exist yet. Most AI today is narrow, focused on specific tasks. Key concepts like machine learning allow AIs to learn from data rather than explicit programming. I hope this overview has helped demystify some key aspects of artificial intelligence. If you found this video helpful, please give it a thumbs up and share it with your friends. Don't forget to subscribe to my channel and hit the bell icon so you won't miss our next video, where we'll dive even deeper into the world of AI. If you have any questions or thoughts about AI, drop a comment below. I'd love to hear from you. Thanks for watching, and we'll see you in the next video.